Okay, so for my next special segment, once again, guys, all right, we are coming from vertex C because that's what it says in the directions, okay? And we're trying to find the altitude this time. All right, so let's do a quick recap of what an altitude is. So an altitude is the perpendicular segment connecting a vertex and the opposite side. All right. All right, so if we take a look, all right, and once again, if I'm asking you guys to draw, all right, the perpendicular segment, all right, where I would draw it would actually be on the outside, all right, of the triangle, all right, because remember, we can draw it to the line containing the opposite side, okay? But, all right, what I'm looking at is this segment right here, okay? So it's coming from vertex C, and it's perpendicular to AB. All right, and if it's perpendicular to AB, what we know is that the slopes have to be opposite reciprocals, okay? So to start this question, what we're actually going to do is we're actually going to find the slope of AB, okay? So we're going to find the slope of segment AB. So once again, my point of A is 0, 0. My point of B is 12, 6. And I'm going to find the slope of that line, all right, which means I'm going to do 6 minus 0 all over 12 minus 0, which means that my slope is 6 over 12, which reduces to 1/2. Now, I don't want that slope because that's the slope of AB. What I want is the perpendicular slope, all right? So if we remember, all right, my step 2, my perpendicular slope to AB is going to be the opposite reciprocal of that, which is going to be -2, okay? So that's going to be the slope of our altitude. And so now what we need to do is we need to write the equation of the altitude. And what we're going to use is we're going to use our perpendicular slope and the point it's telling us it has to pass through, all right, which is vertex C. Okay. So my perpendicular slope is -2, all right, and my vertex C is 18, 0. And I now need to take those and I'm going to plug them into point slope form, okay? So I'm going to get y minus 0 equals -2 times x minus 18. All right, y minus 0 is y equals, I'm going to distribute the -2 through, so -2x plus 36, and that's my final answer. Can't go any further than that. Okay. All right, so we're now going to write, for our next example, the equation of the perpendicular bisector, okay? And if you notice, this one isn't telling you what vertex it has to pass through because perpendicular bisectors don't have to pass through a vertex, okay? All we know about a perpendicular bisector is it has to pass through the midpoint, which is the bisector portion, and it has to be perpendicular to that line. So this is kind of putting everything together, okay? So what I want to do is, I know it's not going to be an exact representation of this, but I'm just going to sketch, all right, segment AB. And if I ask you guys to draw, all right, the perpendicular bisector of AB, the first thing you'd have to do is to eyeball the midpoint, okay? So that's going to be our first step. So our first step is to find the midpoint of AB, okay, using our midpoint formula, all right? So using our midpoint formula, we're going to do 6 plus a -6 all over 2, comma, 2 plus 10 over 2, okay? So 6 plus a -6 is obviously 0, divided by 2 is 0, all right? 2 plus 10 is 12, divided by 2 is obviously 6, okay? So that right there is my midpoint. Now the next thing, if I asked you guys to draw the perpendicular bisector, is you would draw the segment that is perpendicular, all right, to AB. So if it's perpendicular to AB, that means that we now need to find the slope of AB so that we can make it perpendicular to it, okay? So finding the slope of AD, or AB, we're going to do 10 minus 2 all over -6 minus 6, okay? Which turns into 8 over a -12, which reduces into negative 2/3. Okay. But remember, I don't want that slope. All right, what I want is the perpendicular slope. All right, so my third step is my perpendicular slope, all right, which is the opposite reciprocal, all right, to that slope of AB, which means my perpendicular slope is 3/2. All right, so we now have all the components to actually write the equation of the perpendicular bisector, okay? And so the equation of the perpendicular bisector is going to be using our midpoint and our perpendicular slope. So it's the combination of the two. All right, now, a couple things. This point of the midpoint, 0,6, is actually pretty significant because it's the y-intercept, because the 0 is in the x spot, right? So you could actually jump ahead and get your final answer right away, all right? But I'm going to work through it, all right, just so that you can see that you can't do that every single time, okay? So what I'm going to use is my 3,2 and my 0,6, and I'm going to plug it into point slope form. So I'm going to get y minus 6 is equal to 3/2 times x minus 0. All right, distributing through, you're going to get y minus 6 is equal to 3/2 x plus 0. All right, and then adding the 6 over, you'd get y is equal to 3/2 x plus 6. And that's your final answer. Okay. Now, what I was saying before is that if you recognize that that was a y-intercept, you literally could have not done this portion right here, and you could have just jumped to y is equal to mx plus b, where b is your 6. Okay. All right. So that right there are like the 3 intro special segment equations. Okay, so we have a bunch of practice problems. All right, what I'm going to do is I'm actually going to do the next 3. All right, if you would like to kind of jump ahead and just do them and then go back and check, you can absolutely do that. If you're struggling and you want to hear it all over again, all right, I'm going to go through them. Okay, so do what you need to do. All right, but in the next video, I'm going to explain, all right, the next 3 problems, all right, that we did that were very similar to what we just did.